Welcome back, students. Let's resume our discussion on section 2. We went through these types of problems, the problems regarding the y-intercepts. Now let's go over to problems about the x-intercepts. And the standard technique is here in subsection 2.4, but let's try one problem without the proper tool, and let's see what happens. Okay, let's go to problem 2.5, excuse me. Find the vertex equation of the quadratic function that has minimum -2 and have the x-intercept 1 and 5. All right. And then what do we have? We want vertex equation. And then minimum is -2. So k is -2. And x-intercept 1 and 5. Okay, x-intercept is 1, which means running through 1, 0. And x-intercept is 5, which means running through 5, 0. So we have 3 pieces of information for 3 parameters to determine a, h, k. K is already there, that looks good. All right, so that looks good. Y equals a, x minus h squared minus 2, right? And here, let's plug in x is 1 and y is 0. And also, in the same equation, let's plug in x is 5 and y is 0. Okay? So we have 2 x-intercepts, x is 1 and x is 5. So for each case, y-coordinate should be 0. The graph is cutting through the x-axis, so y-coordinate is 0. So if I plug those in, what do we have? All right, y equals to 0. So a times 1 minus h squared minus 2 is equal to 0. This is what I get from the first. A times now 5 minus h squared minus 2 is equal to 0. That's what I get. And then from here I have to find what is a and what is k. Now, at this moment, I'm running out of ideas. What should I do? I mean, we have 2 unknowns, a and h, and 2 equations. Looks like it's well posed, but here's a bit of a problem. This is not a system of linear equation. This is a system of quadratic equation. Not impossible, but it's going to be really messy. Shall I just go on? Well, of course, there's a reason I put question mark here as a solution. And I told you in advance, we have to use this intercept form, but we skipped it. And there are circumstances that this may not work very well in any case. So let's stop here and let's do it properly. The reason it didn't work very well is because we encountered a system of quadratic equations. Not impossible, but it's a huge mess nonetheless. So how do we handle this kind of problem? Here, the intercept form of the quadratic equation. You see, f of x is given like this, and x-intercept means y-coordinate is equal to 0, which means this f of x is equal to 0. So set it equal to 0. Now we have quadratic equation to solve. One way to solve it is to factor it and set it equal to 0, if possible. Now, if it is possible, then we get x minus r is equal to 0, so x equals r, and x minus s equal to 0, so x equals s, and then those two are two real zeros. If it is not possible to solve it like this, maybe you'll have to use quadratic formulas for r and s in any case. And we have this kind of factorization. Here's some visualizations associated to that. You see, we have r and s, we have r and s, and that's related to this form. Moreover, from here, from these few pictures, let's apply some symmetries. Symmetric with respect to x equals h, the vertical line, the line running through the vertex. So the vertex must be right in the middle. That's how I'm getting h equals r plus s over 2, right in the middle of r and s. So if you have r and s, we automatically have h as the average of the two, and k follows from the function value of h, because whenever you have x coordinate value here, y coordinate you can find out by plugging it back into the function and then calculating the y coordinate value. So if you have r and s, automatically we have h, and then with a bit of trouble we can find k as well. Here's a graphical justification, by the way. I'm afraid this doesn't always happen. When we have two real zeros, yes, but in some other cases like this, no real zero, so graph is not touching the x-axis at all. In that case, things do not really work out very well. And if we have just one zero, the double zero, in that case, things are a bit different still. Let's come back to this problem. Now let's use the correct solution or proper solution. I mean, previous solution was not really impossible. It works, it's just that it's really messy. Okay, here we go. Y equals 8 times x minus 1, x minus 5. That's what I get from x-intercepts 1 and 5. Furthermore, h is automatically following. Six over 2, h is 3. And k is f of h. And okay, this is my function. So that is 8 times h minus 1, h minus 5. But wait a minute, what is h? H is 3, isn't it? Oh, never mind. I'll just take one extra step. 3 minus 1, 3 minus 5. And k value in this problem is -2. So from here, can you determine what a value is? Yes, I can. So 8 times 3 minus 2, 3 minus 1 is 2, 3 minus 5, -2 is equal to -2. Therefore, a is 1/2. -4, yeah, that's right. So f of x is 1/2, x minus 1, x minus 5. So, by the way, let's go back to f of x here. Y is okay, but I've been using f of x in other notations, so let's follow that. All right, we have that. And then, oh, wait a minute, what am I thinking? I didn't have to go back and determine f of x here. I found a value, I have h value here, and I have k value there. There's no reason to go back and do this. 1/2 x minus 3 squared minus 2, and that's sufficient. And never mind, I'm going to take one more extra step. There. So a is 1/2. And h is 3. And k is -2, which came directly from the problem. Okay, let's recap both methods. First method, we are trying to work directly from that vertex equation. And then we have k equals to -2, okay, minimum is -2 here. And then x-intercepts are 1 and 5, so 1, 0 and 5, 0. Plug those in and try to determine h. We ended up with a mess. I don't know what a, I don't know what h. And then we have a couple of quadratic equations to work out, a system of quadratic equations. It may not be impossible, but it's a mess. Now, using the intercept equation, we have x-intercept 1 and 5. I can put those directly in. And then I only have one character to determine. Not a system of equation, just one equation. I don't know a, and I can find out easily. H immediately follows, and then k immediately follows. K does not immediately follow, excuse me. You have to go back to original equation, that's equation here, to find out k. So okay, k requires a bit of a work. H follows immediately, k does not. From this k part, we can determine what a is, and that's what we did here. Once you determine the a, okay, we want fa, h, and k, so we have the vertex equation. How about the next problem here? 2.6. Find the vertex equation of the quadratic function that has maximum 3. So this one has minimum 2. And this one has maximum 3. So similar. And x-intercepts are 1/2 and -5/2. Do you think this is very similar problem? It should be. Y equals to a. No, let's use f of x. Here, x-intercepts are what and what? 1/2 and then -5/2. So, like this. And then whenever you have R and S, H follows immediately. 1/2 plus 5/2 over 2. And what is it? 4/2, -2 over 2. If I did it right in my mental math, H is -1. The rest is left to the students. We have intercept equation, and H follows immediately. As for K, you need some work, and that's what I'm asking you to do and complete the problem in the end. Once you have A, H, and K, then you have everything.